All right, folks. Welcome back. Happy Monday. Hope you guys are doing well. Thank you for finding this video. Basically, what you're going to do today is, I'm sure the sub explained, go through this video, watch it, and try and complete the assignment that I'm going to go through a little bit in the video, but hopefully you guys will be able to finish it on your own. All right, so let's jump right into it. And let's read the problem here. And we kind of started this work. It's going to look a little bit different, and it looks like a lot's going on here, but I think you'll catch on, all right? So it says, Mariana is curious how much money will be in her account when she is 18 and graduates from high school. So she made some graduation money, and she's going to put some of that away in an account and let it build some interest, all right? She went back to the table she created, and she looked at the numbers in the first two columns. She noticed that there's a pattern, and she thought she could rewrite it a little shortly. So if you remember from the other day, we had a table that looked like, let me see if I can bring it up here, like this, where it says her grandfather gave her some money, 5% interest every year, and it's compound interest. But you can see we had three columns, and we took the 500, we took 5% to get the 25, and then we added that 25 to the original 500, and we kept taking 5%. 5% of 525 is 500, or is 51.25 cents. We added that to the original 500, and we kept doing that. We had three columns, okay? But there's a simpler way for us to do that, and that's this table right here. And you can see it's got the same numbers. Look, 500, 525, 551.25. You can see right there, the second column, those are the same, 500, 525, 551. Okay, so this is a simpler way to write what we did on Friday. All right, and so let's see here. Let me see if I can bring this up. So what's happening in this table is this. You can see at 0 years, she puts in $500. Okay, after a year, she's going to have $525. Now, how did we find that? You can see right here. That's how we got that. We took 500 and we took it times 1.05. Now, what does this 1.05 mean? Because it shows up a lot, as you can see. And that's what this arrow means. Look, times 1.05. So 500 times 1.05. What does that 1.05 mean? Well, think about when you take something times 1, okay? It's just itself, right? So 500 times just the 1 is 500. So we're able to use that 1 to represent itself. All right, so 500 times 1 is itself, and then the 0.05, that's the 5%. Oops. That's the 5%. So by taking 500, let's see if I can do this here. 500 times 1.05. We don't have to add the 500 back. What I mean is, before we did 500 times 0.05, right? That's 5%. Then we added the 500 back. Taking it times 1.05 is just a way for us not to have to do both steps. All right, so that's automatically, by taking 500 times 1.05, that's adding the 5% to our original without doing it in 2 steps, okay? So that's what that means. So 500 times 1.05, it adds the 5% in to the original 500, all right? Now, what happens next is kind of important. When you go from this step, 525, to this step, 551.25, you're not just taking 5% of 500. You're taking 5% of the previous step, 525. So what's happening here is it just keeps building on itself and multiplying times another 1.05. Let me use some different colors here. From 500 to 225, we took 500 times 1.05, okay? That's in red, all one step. Then we didn't just take 500 times 1.05, we took 525 times 1.05. But what it shows is, here's our original 500 times 1.05 times another 1.05. So from the original, we took it times 1.05, then times another 1.05. That's how we got to here, looking green. There's your original. Here's the second 1.05, and here's the third 1.05. You can see at each step, you're just multiplying times another 1.05. So after 1 year, 1.05 times 2 years, there's two 1.05s. Times 3 years, there's three 1.05. So you're just taking that 1.05 times the number of years. Okay, so it's just you're constantly building on itself. So the next step, when we would go to, let me do it in one more color here. To get to this interest, you'd have our original 5% times another 1.05 times another 1.05. And how many would there be? It's 4 years, so there'd be 4 1.05s. 1, 2, 3, 4. So if we wanted to look at the interest 20 years down the line, let's say she just let this money go. You take 500, 20 years down the line, you take 500 times 1.05 20 times. I'm not going to write that out, but you just keep taking it times 1.05 20 times. All right. So let's go back to the sheet here. So it says, as Mariana works down the table to fill in entries, what changes in her calculations? What patterns do you see? Every time you bump up a year, you're multiplying times another 1.05. You're constantly taking 5% of what came before it. Okay. B, her calculations for 2 years. What does this represent? The 500 times 1.05. That's the original. That's after a year. And it shows up every time. Let me see if I can use a different color here just to represent. Use the red. Look, the original 500 times 1.05 shows up every time. In blue, this is 2 years, so you added an additional 1.05. Look at 3 years, there's 2 more 1.05s. So that original 500 times 1.05 here, that represents the original, really the first 5% taken. The first 5% taken. And it's equal to 525 because we took 5% of the original. That was the first step. So it says, how could we rewrite Mariana's balance at the end of any year in terms of the principal 500? As in, like I said, what about 20 years down the line? We don't want to sit here and take it times 1.05 20 times. There's an easier way to do it, which we'll get to in a second. Just I want to read D real quick. Based on this pattern, describe how you find Mariana's balance after 18 years without finding the first 17 years. Okay, so let me try and answer C and D for you, because here's ultimately the question for C and D. Okay, let me add a slide here. So after a year, our original was 500, right? After a year, we take it times 1.05. That gives us that 525 after a year. Okay, after 2 years, here's the first year. But in order to do the second year, we have to put another 1.05. That gave us the 551.25. All right, so this was after 1 year. This was after 2 years. So you can then see after 3 years, the way you do it is just your original 500. Here's the first year. Here's the second year. Here's the third year. So if you're talking then, 20, they're talking 18 years down the line. See if I can move this here. They're talking 18 years down the line. You would have to take you'd have to take 500 times 1.05 times 1.05 times 1.05 18 times. Okay. Not that that's impossible. You could certainly put that in your calculator, but you'd have to count, you'd have to do 500 times 1.05. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So with the calculator, that ends up being pretty easy. But still, if you wanted, 100 years down the line, you'd have to sit here 1, 2, 3, 4 until, you did 100. All right. So we're looking for an easier way to write this, basically. And the thing about it is, how do we write multiplication a whole bunch of times? That's the question. Okay. And if you look at the worksheet, it kind of gives it away down here. It's exponents. Exponents represent multiplication done a whole bunch of times. So when it comes to this investment thing, 500 was our original, right? We're taking it times 1.05, depending on how many years, right? If it's 3 years, we do this 3 times. If it's 18 years, we do this 18 times. Multiply times 1.05, 18 times. So rather than write that out or type that out, here's the trick. Let me actually use a different color here. You're going to use an exponent, and you're going to put it on the 1.05. Think about it. That 500 is the same no matter what example we have, right? There's always going to be the original investment. All right. This is the interest over X years. So it's the interest over, however many years we want. For example, if we wanted to do 3 years, this is what we do. We take 500 times 1.05 up to the power of 3. That's 3 years. All right. So you would do, see if I can do it here, 1.05 up to the third power, and then times 500. There it is. You can check your table. It should be 578.81. What about over 18 years? You would do 1.05 up to the 18th power times 500. I think that's right. I think that's what we got before. So it would look like this after 18 years. Sorry, that should be a 5. Up to the 18th power. If we wanted 100 years, it would be 500 times 1.05 up to the 100th power. So for C, how could we rewrite it? We could use an exponent. Every step has 500 times 1.05. It all depends on how many 1.05s we're going to multiply by. We're going to do that every year. So over 20 years, we would have 20 1.05s to multiply by. Okay. And so based on this pattern, how could we do it for 18 years? You just, right here, it would be 500 times 1.05 times 18. I'm sorry, not times 18, 500 times 1.05 to the 18th power. All right. And so this is how we would generally do it. So this is part C. And then part D, we would put it to the 18th power, right? So ultimately, we're going to learn about exponents, and I want you to go ahead and try and do 816 and 817 on your own, okay? You don't have to finish it. When I come back on Tuesday, we'll talk about it, but thank you for watching the video. Appreciate it, guys. Take care. Try and answer these questions based on what I talked about, and then 816, do on your own. Take care, guys.